welcome to another video. This one relates to Ancova. It's from Fields Chapter 11. Alright, so I'm going to be following this general outline, which is I'm going to load my libraries, load my data, run descriptives, which I generally do. I'm going to test some assumptions, create a model, test more assumptions, create some contrasts, run post-hoc tests, and then we have two ways of dealing with an Ancova. If somebody can find a better way to run an Ancova with more than one value, so more than two values of the group variable, let me know. I could not. Alright, so step one, load my libraries. The libraries I'm planning on using, I'm just going to paste them all in, and then I'm going to hit Control L to clear the screen, so that went away. Alright, I'm going to grab my data. In this case, I'm using the Viagra covariate data. So I'm going to go grab that. Alright, and then first thing I'm going to do is to relabel. If I want to, I can run a summary on this to see that they still, for whatever reason, are not labeling them reasonably. But we have doses 1, 2, and 3. They aren't labeled. So to label those, I run this command. Now if I run the summary again, I should have placebo, low dose, and high dose. Excellent. Now I'm going to run a quick descriptive statistic, kind of look at how these things just break down. So my placebo group has an average of 3.2, my low dose group has an average of 4.8, my high dose group has an average of 4.84. That's all I'm looking at. Okay. Now I'm going to run some descriptives for the two variables that I'm going to be interacting with, which are the patient's libido, in this case run as D libido, which has an average of 4.36, and the partner's libido, which is the partner of the patient, which has a 2.73. So we can conclude from this that, okay, even the lowest, the placebo effect libido was still higher than the partner's libido, and all of these are greater than the average for partner libido. Okay, so now we're going to run some tests on assumptions. First test we're going to run is Levine's test. It is a value of 0.72, not significant, we move on. Next test we're going to do is to make sure that the partner's libido and dose are independent of each other. We're going to use an Ancova test to do that. And that has a p-value of 0.158. So we didn't violate the first two assumptions. As we continue, we're going to create a model. And if we're making this model, we need to realize that it's not going to be the one we use contrast with later. So I have my model. I can run an Ancova type 3 on my model. And at that level, we say the partner's libido appears significant and the dose appears significant. Now we haven't made it through all of our assumptions yet, so it could be that something here has a problem. Next up, I'm going to do my homogeneity over the regression slope analysis, which just takes the interaction between partner libido and dose, and I find that that interaction is significant. That violates an assumption. At this stage, I can note the violation and continue, which is bad form, or I can try to run a robust Ancova. Now the robust Ancova gets really messy really quick with the way this variable set exists, where we have the three layers, the placebo, low, and high. So we have the option of recoding low and high into dose, so we have basically Viagra and no Viagra, in which case we would be able to run a Ancova. I'm not going to do that in this example. So next I'm going to make my contrasts so we can see the contrast. And unlike the last few times I've done it, I'm actually naming these contrasts ahead of time, something that'll make sense. So none versus some, and low versus high. I'm then going to add those contrasts by name to my variable. That way I'm going to keep those names. Oh, and we run into my first error. The reason this is an error is I wanted to have this underscore here, so I need to make my variable first in order to have the underscore. So all I'm going to do is take my d cache dose underscore new variable and add to it what the old variable is. And that's the only reason I'm doing that is for ease of reading stuff. Viagra data not found. It should be D. We'll get there. Take a second. Alright. Dose. Yeah. D. Great. 5 times later. We're good. Now I'm going to make a new model. and this model is going to be named model contrast. And I can run my summary on the model contrast, which is different than my first model, and that's going to give me a significant value at none versus some, but not a significant value at low versus high. Okay. Now that we've done that, we have an option for some post hoc tests. This p-value here of 0.10 says that the overall model set up here isn't significant. That's not really important to us. We were more looking at the individual variables. So, running the post hoc test. As I summarize my post hoc, I have a high versus placebo as significant, high versus low as not significant, and low versus placebo as not significant, but close to. Okay. So that's all well and good. Recall that we did violate an assumption earlier, so all of this should be taken with a grain of salt. And then we can run one more post hoc test if we want to, which just gives me the estimates of upper and lower. So the high dose versus placebo, you'll notice, does not cross 0, so we would call it significant. Negative to a positive crosses 0, negative to a positive crosses 0. Alright, on to robust Ancovas, which is exciting. So, like I said before, we did violate our assumption there. This is a robust Ancova option, but it isn't ideal. The reason it's not ideal is we don't have that library. Grab that library first. Sorry. I think it's WRS, which you'd think I would have loaded when I said I was loading all my libraries. Is that right? Yes. Alright. So that will run my quick little bootstrap for me. And it gave me a significant p-value. Now, one of the things to remember about a bootstrap is it'll have a different number every time you run it. So this is 0.051. This is same, of course it is. It should have a different number each time. My math is it's not doing it. Alright. Anyway, you guys will not necessarily get the same number I do, and that first number wasn't the same. So this is giving us some errors. Like I said, this is not an ideal way to run an Ancova's bootstrapped test or robust test, mainly because we can't do much more than that. We got a significance value out of it, but we can't explore too much. In contrast to that, in the event we have a set of data that has just 2 values, then we're going to run this kind of data. So ANC boot, the dependent variable by group, and covariate. If the group only has 2, a yes-no scenario, then we can run that. So he has in his data set invisibility data, which I'm going to go load in right now. And then we'll just show you very quickly what that is and move along. This is again fields data, and it's under cloak of invisibility. So I can run a summary there, just so we can get an idea of what's in it. Actually longer than if I typed it. We have whether or not you're wearing a cloak, with only 2 options, a 1 and a 2, which is why this particular Ancova is going to work, and our mischief at time 1 and our mischief at time 2. You'll notice that those are for the same person. Kind of important. Okay. So, with that done, here we're trying to predict mischief 2 by whether or not you have a cloak, given mischief 1 is a covariate. And it says no. The reason it says no is we need a factor for my cloak. Let me go grab that code real quick. Which I should have. Sorry, guys. see how long that is, which is why I chose to go find it. Alright. Okie dokie. So having run our bootstrapped Ancova here, we can say, based off of basically what it did was break it down into different levels that we're examining, and we can look at the p-values for each of those levels. So this value of 4 here appears significant, the value of 6 here appears significant, as does 7. So we have 2 at close to but not significant. Remember, your data might not look exactly the same as mine. So we can say from this that at these different levels you can talk about the different significance of the interaction. In other words, you can say those people with relatively low mischievousness do have a significant difference, and those with relatively high mischievousness do appear to have a significant difference. But if you're somewhere in the middle, it doesn't appear that we can tell one way or the other whether or not your level of mischievousness has changed. Alright, that's Ancova.